I think you'll find learning objective 3 very interesting because here we begin to see the actual numbers that we will utilize in our business making decisions. So we're going to calculate some of the variances for direct material and direct labor. So to begin the process, we have to have the flexible budget. That's why we started our discussion with a flexible budget. And you can see from the budget that's been prepared here, we actually produced 52,000 units of crayons. Okay, and I have the actual cost. Okay, this is what happened in my actual production of 52,000 batches of crayons. So what I want to do is compare my actual to a flexible budget for the amount of crayons that I actually produced. Okay, and we can do that because when we were estimating our standards for the cost of materials, we estimated the cost of labor. We estimated that direct materials cost $175 per unit, so 175 times 52,000 units is going to get me $91,000. So we actually spent $104,000 on direct materials for 52,000 units when we thought we should have spent $91,000. This is an unfavorable variance. We need to be able to break it down into the cost and the efficiency variance to see what operations need to be changed to get this unfavorable variance under control. The same way, we've estimated $3 of direct labor per unit. If we take that times 52,000 units, it shows us that we should have spent, based on our standards, we should have spent $156,000 on direct labor, but we only spent $145,600. So this is a favorable variance. Now, do we just move on because this is favorable and not analyze it? Not necessarily so, because between the cost and the efficiency variance, the cost variance could be favorable and the efficiency is unfavorable, or vice versa. So just because it says favorable doesn't mean that we don't have an issue that we need to analyze. So you can see the process here. Let's move forward with the actual calculation of we got the direct materials cost variance here in total of $104,000, but let's break it down into the cost and the efficiency. Okay, and so if we'll take a look, remember we said we want to look at actual cost less standard cost times the actual quantity. Did I pay more or less per pound than what I thought I should have spent on these materials? Okay, our standards have dictated that we should be spending $1.75 per pound, and our standards say that we should be spending using 1 pound of paraffin per batch. Okay, so this is what I'm using for my budget. These are my standards. But what actually took place, okay, was that I purchased 65,000 pounds of material for $104,000. So think about, we want actual cost less standard cost. I know my standard costs are $1.75 per pound. How do I get the 160? Well, I spent $104,000 on 65,000 pounds. So $104,000 divided by 65,000 pounds tells me that I actually spent $1.60 per pound. So I thought the paraffin should cost $175. It only cost $160. I know right now that this is a favorable variance because I spent less per pound than I thought. How much? The difference of 15 cents a pound times the actual number of pounds that I actually used. So I purchased 65,000 pounds and I paid 15 cents per pound less than what I thought that I should have. So I have a favorable materials variance, cost variance of $9,750. That's a good thing. Unless purchasing cheaper materials means I purchase cheaper quality materials, which means that the paraffin may not melt correctly. It may jam my machines. So for whatever reason, if I bought a lower quality material, then is it going to cause problems with my efficiency variance? Okay, well, this was cost. Let's move to the next slide and look at efficiency. Okay, well, with the efficiency, we're talking about the quantity. Okay, so how much actual paraffin did I use compared to what I thought I should use? So if we remember back to this slide, we purchased 65,000 pounds. So my actual quantity is 65,000 pounds. How much paraffin did I think it was going to take? We said $1 per pound, and we manufactured 52,000 units. So 52,000 units, when we think they should take 1 pound each, generates 52 pounds as our standard. So now Notice our difference. I thought I should use 52,000 pounds of paraffin, but I actually used 65,000. We multiply that times our standard cost per pound, and now I have this unfavorable variance of 22,750. Okay, so if we, so once again, we know that we paid less per pound than we thought, but for some reason we have used more. So who did we say is responsible for this? The production manager. If I go to the production manager and I say, why are you using 13,000 more pounds of paraffin than you should have in this process? And my production manager, who doesn't want to take on or bear responsibility, says, well, this isn't our fault. That purchasing agent bought cheaper materials to save some money on his end, and these cheaper materials wouldn't melt correctly. They kept jamming up our machines, so we continuously had to use more materials. Well, we can't just stop there. Okay, if you're an accountant or a manager, you got to have that critical thinking process to say, okay, well, let's just check into this further, because if this is the case, then I'm probably going to have more direct labor hours than I estimated as well, because we're having to rework some things. So think about how the big picture should come together. So if we take a look at our direct materials, what we see was we had this unfavorable variance. And so if I go to my purchasing agent and say, hey, we've got an unfavorable variance in materials, what's going on? He's going to say, it's not my fault, because I was able to get our materials for 15 cents a pound less than what they should have been. I'm going to say, well, our manager out here says that you've impacted his efficiency ratios because you've bought cheaper, lower quality material. And what happens if the purchasing agent says, no, we got a quantity discount. I purchased the exact same quality of paraffin that was required by the engineers. There's not a problem on my end. Then we have to be able to figure out, what is actually going on here. But understanding what's driving these variances and how we can get to the root of those variances to fix them. All right. So can you see how much more useful and more beneficial understanding that this $13,000 unfavorable variance comes from two completely different components of the manufacturing process, and it gives us some idea of where to start making decisions to improve our efficiencies to improve these variances. Now, the direct labor variance, on the other hand, the same way, if we're looking at our cost variance, we want to know what was the actual cost that I paid my people per hour versus what I thought I was going to pay them per hour. Well, our direct labor standard was $12 per hour, and we estimated that it should take a quarter of an hour per batch of crayons. These are our standards. Okay, but what actually happened here was that I paid direct labor of $145.06 for 10,400 direct labor hours, which means that I actually paid $14 per hour. So my actual costs are $14 per hour. I estimated 12. So I know right from the very beginning this is an unfavorable variance because I spent $2 more per direct labor hour than I should have. Multiply that times the number of direct labor hours that you actually worked, and we have an unfavorable variance in this total variance that was favorable. Okay, so I've paid more per hour than I should have. How did that affect my efficiency? Well, let's take a look. Efficiency is not based on cost, it's based on quantity. How much actual paraffin did I use compared to what I should have used? Okay, direct labor hours. How many direct labor hours did I actually use versus the number of hours that I thought I should have used? Well, if you'll back up, we used 10,400 direct labor hours. That's our actual here. The standard, let's back up. Our standard said we think it's going to take a quarter of an hour for each batch of crayons. How many batches? 52,000. So 52,000 times 0.25 is 13,000 direct labor hours. This is what we thought it should take. So now look at what happens. I thought it should take 13,000 hours, but it only took 10.4. I have a favorable variance here. And so what's could be taking place, I hired more skilled workers. I paid them $2 more per hour, and as a result, they did the job more efficiently. And in the end, I have a complete or total comprehensive favorable direct labor variance. And why did that happen? Because I have unfavorable here. I paid my people $2 more per hour than I thought, but in the process, it didn't take them as long. So the next time we prepare our standards and the next time we prepare our budget, we may want to reconsider, is it really worthwhile just to hire more experienced workers who are more efficient? Okay, so once again, I hope that you can see from these slides how we can take this total variance, break it down into its different components to see how our actual performance is comparing to our benchmark or standards that we have set for it. So take a break here, make some notes again, and we'll come back and begin with learning objective 4.